How did we get here? Oh, I remember. Initially, we just wanted to test this app. We type a few keywords and the app fetches cookbooks from Google Volumes API. For such a simple app, an end-to-end test might sound like the right fit at first, but you will often realize that the results from the backend might change on each run. You might hit rate limiting or boat detection or some quota of some sorts. Or you might have so many tests that the backend can't stand it. Debugging is also harder. Isn't it a problem with the UI? Nah, I think it's the store. No, I think it's the backend. It's always the backend. Maybe there's just something wrong with the data from the database. I think it's the testing spirits. Where should I put the breakpoint? Finally, you might just not be able to work offline, or when the testing or staging or sandbox APIs you're relying on are down for some reason, then you just can't work at all. It might sound as a rare occurrence, but it happens way too often, especially with some providers that I won't name. Yeah, it's them. That's when we decide to narrow down our tests and cut the connections with these dependencies that can range from remote services like our example here to browser APIs or anything related to the infrastructure. The thing is that we can't really cut these connections. First, because these are not real scissors. And we can't just prevent the code from flowing like this. We need a test double to replace the real implementation. Just like the movie industry, there are stunt doubles to replace actors so that we don't break them during our extreme testing scenarios, as they might be fragile or expensive or also flaky and unreliable. What did he say? Keanu Reeves does his own stunts, so he might prefer end-to-end testing. Seriously. A common approach in the JavaScript ecosystem for test doubles is to use spine stubs. They're often called mocks, but mocks are a different thing that you can read more about in my cookbook. Or if you want to deep dive into the different types of test doubles, when to use them and how to use them properly with exercises and everything, then you should definitely check out my video course, and you'll find the links in the description. Back to spine stubs. They usually look like this, whether you're using Jasmine, Jest, or VTest. I personally call them spine stubs to avoid any confusion because they're both spies and stubs. They're stubs because they allow you to arrange the tests by programming the return values, and they're spies because they allow you to verify how they were called. Back to our previous diagram, let's zoom in a bit. The test double here is just a stub for now, because the test arranged it to always return a burger and a pizza. Then we interact with the system under test, which will call our stub with some arguments. The stub will return the pre-programmed value. Now, what makes this stub a spine stub is that it remembers each call that was made to it. So when we called it with YOLO, it stored that call in memory. That's how we can later check how our spine stub was called. Okay, let's try it out. Let's describe our first test. Let's implement it. Now we have to create a spine stub and return it here so that the test can use it. Let's create the spine stub. Let's keep it type safe. Let's pre-program it with the returned values. This has to be an observable. Now let's replace the real dependency with the spine stub. We can return this spine stub to our tests. Let's make sure it's called properly. Let's enable our tests. And our test is passing. Now let's implement the other test where we want to make sure that the keywords we type are forwarded to the repository. Let's enable this test. And it is passing. Great. Looks like there's nothing to dislike here. Now let's stress test this test. Whoa, this is a strong tongue twister. Now, okay, let's go. Now, what if we refactor our parameters into an object? Our service was refactored properly. Our component was refactored properly, but our tests are broken. Now let's have a look at the tests. Well, we're still expecting the keywords as the first parameter, but actually we should be expecting an object. So we have to fix this test like this. Now our tests are passing again. And I know what you're thinking. Maybe Cursor or an AI agent would have got it right. Or maybe not. And also, do you really want to change your assertions each time you refactor something? I'm not sure. That could be really fragile. Now, what if we had hundreds of tests stubbing this service? We would have to change all of them, and that would be terrifying. This clearly indicates that our tests are sensitive to structural changes, and that can either discourage us from refactoring or make testing way more expensive. Now, what if we refactor our component and inadvertently ignore the search results when typing keywords? The result here is just ignored for some reason, and the keyword signal is not updated, so the resource is not updated, and the view is not updated either. But our tests are passing. Fantastic. So this is a false negative. Our tests are passing, but our production code is broken. You did this? You think it's funny? Sorry. Let's see what's wrong with our tests. We should have reprogrammed our stub before typing keywords and then checked what's displayed in the view. Now our test is failing. Let's refactor back. And now our tests are passing. You can already see that it's easy to forget something and that the test is becoming hard to reason about. And imagine that we're not the ones maintaining the repository, so we don't really know how it behaves, so we're just trying to mimic the behavior without really knowing. While this might look straightforward for some of you, it can be way harder. Was the spine stub called twice more? Is that important? Is the order important? What if there is a debounce? Is it valid to always return the same value here? Shouldn't I return a different value for each keywords? How can I make sure that the expected keywords and results stay correlated? So many things to worry about, right? Tests should be safety nets, not minefields. A better alternative is the fake. The fake is just a class that implements the same interface as the real dependency. It just has to be as simple and self-contained as possible. Let's try it out. We create a new file for the fake. We just create a class. Note that this is type-safe by nature. I cannot return whatever I want. I cannot return undefined just like stubs do even when they're typed. Doesn't work. Doesn't work. But if I return an observable with a list of cookbooks, then it works. Now we just need a property to store these cookbooks. And I'm going to return them here. If you're using observables, you will want to put the work in a defer function because you don't want to evaluate the cookbooks array before the user or the caller subscribes. Now we can either choose to not implement the keyword filtering for now, or if we need it for our test, we can just go ahead and implement it. Now we can just add a configure method so that we can orchestrate the fake from the tests. As you can imagine, this will always be consistent because if, I don't know, if tomorrow we have like a new method like add cookbook, then this will update the cookbooks and the results will be okay. If we have another method like search cookbook facets that takes some keywords and returns some search facets, then it will use the cookbooks in memory and group them to generate the facets, for example. This means that all the methods here will be synchronized compared to a stub where you have to program each method independently, and then that's where the inconsistencies come from. Now the cool thing is that it is reusable, and also it often lives not far away from the real implementation. So thanks to this co-location and the fact that they share the same interface, whenever we change the implementation or the interface, we'll have to think of the fake. So the person or the maintainer of the implementation will have to maintain the fake. So they will always be symmetric. Now, in order to use it with our Angular tests, we have to make it injectable because it might inject dependencies too. And also we will create a provider factory to make it easier for our tests to use it. I want to return environment providers. We want to override the real implementation with the fake. This should work, but in order to call the configure method on the fake, we would have to inject the cookbook repository and downcast it to cookbook repository fake, which can be error prone and hacky. It's better to provide the cookbook repository fake. But this way, we would end up with two different instances of the fake, one as the cookbook repository fake and one as the cookbook repository. So in order to use the same instance, as this is what we want, we have to use existing. So injecting the cookbook repository or the cookbook repository fake will return the same instance, but they will return a different type. This way, when we inject the fake, we can call the fake specific methods such as configure. Let's try it out. Now I can inject the fake just before the component is rendered and configure it. Let's move to the test. Yay! Our test is passing. Now let's move to the second one, which is more interesting. We need to type some keywords and see that the results are updated. Now let's check that there's only one cookbook displayed. And ta-da! Our test is passing. And the find by role method would have thrown an error if there were like two cookbooks displayed. We can see this by just removing this line. And we can see that our test is failing because there are two cookbooks there. Looks like our tests are now easier to implement, easier to read, and easier to maintain, and also easier to debug. Let's move to our fake. I could put a breakpoint here. I could add a console log. And I can see how many times this was called with which values. If you're wondering how come these logs are inlined in the IDE, drop a comment to encourage me to make a video on Wallaby.js, which is the tool I'm using. Now you're wondering, is that all? No, there's more to it. Let's Ballet-proof this and see how our tests survive refactoring when we're using fakes. Let's refactor the search cookbooks parameters to an object. And our tests are failing. Let's see what's happening. Oh, we have an error message. So let's try and debug this. Oh, our fake doesn't seem to receive the expected parameters. Indeed, our refactoring updated the component and the service, but it did not update the fake, sadly. But if we had run some type checking, we would have seen that the fake doesn't have the right type. Also, if I had simply opened my eyes and the project view, I would have seen a problem with the fake. Indeed, it is receiving an object with the keywords in it while it is expecting a string. We have to refactor it to fix it. And it works. What is very interesting here is that we didn't have to touch any tests. We updated our implementation, the usages, and the fake, and that's it. Even if we had thousands of tests using this fake service, we wouldn't have to go through all of them and fix them or ask an AI agent to do so. While if we were using spies, stubs, or mocks, we would definitely have to fix all of them or most of them, or simply give up refactoring. Now let's break our component just like we did with our spy and stub and see how it goes. Let's do nothing with this result. And the test is failing because there should be only one cookbook, but there are still two displayed. And our tests bring us more confidence because they are behavior sensitive. They're like, hey, there's a cookbook missing there. I don't know why, but there's a cookbook missing. You have to debug this. And they are structure insensitive, as they're like, yeah, how does the component call the service? I don't care, that's your problem as long as I have my two cookbooks displayed. And that's the key thing with fakes as test doubles. So what is the bottom line? The problem with the spine stubs, yes, you can call them mocks if you really want to, but technically they are a different thing. The spine stubs test interaction. This makes them structure sensitive and over-specifying. Whenever we refactor something, some tests will fail. On the other hand, fakes test the behavior, which makes them structure insensitive and refactor friendly. Spine stubs are hardly reusable between tests, so they end up all spread out in our code base. This means that for each dependency that is doubled, there may be dozens or hundreds of thousands of developers maintaining a spine stub for each test. Yes, 100,000 of developers. How many developers have stubbed or spied on Angular's router navigate method? I did, and I regret it. Now fakes are a different thing, as they are reusable by design. They are often co-located with the real implementation or its interface. This makes them more reliable because they are maintained by the authors of the dependency we are faking. That is how spine stubs end up with a big cognitive load, in addition of having to master the testing framework's APIs and specificities, while with fakes, you just have to know TypeScript. This also makes spine stubs harder to debug, while with fakes, if you already know how to call console log or set a breakpoint, then you're done. Finally, even though spine stubs try to be type-safe, they are rarely type-safe enough. They return undefined by default, even if it's not valid. The call assertions are often not type-safe, but fakes are type-safe because they are nothing more than TypeScript code. Now, just before you go back to your kitchen and start cooking fakes, here are some few tips that might help you, because I would have loved if someone would have told me about them before. So first, keep them simple. Now, keep them configurable instead of hard-coding lots of data inside. Avoid faking dependencies that you do not control. Create your own abstraction first. Finally, do not go into a fake frenzy and start faking everything. Our pieces of code are sociable creatures. They like to hang out together and be tested together. Thank you for watching, but just one last thing. If you're tired of tests that taste like cardboard, I'd love to invite you into my kitchen. In Pragmatic Angular Testing video course, I share the lessons and the mistakes from nearly 20 years of learning the hard way. My goal is simple: help you write tests that support you, not slow you down. You'll find all the links in the description. Allez, back to your kitchen now, let's cook.